Welcome to our second lesson on refraction. As I had promised, today we shall look at the explanation behind. We go deeper. Okay? So, refraction on plane surface. I've just extracted some figure from our lesson 1. Remember, we had put the pencil in water. Okay? So I want to explain what happens. I've used the tip of the pencil here, the tip of the pencil. This tip can help us understand. Rays from the tip of the pencil. Rays from the tip of the pencil, they will bend at the surface. Okay? Remember, for us to see an object, the rays must reach our eyes. For the object to be seen, for us to say that is a cat, that is a ruler, this is a pen, the rays must reach our eyes. That's the bottom line. Rays must reach our eyes. So for us to see the tip of the pencil, the rays from that tip must reach our eyes. Then we can say that is the tip. Okay? So, rays from the tip of the pencil bend at the surface. But to the eye, the rays appears to be in a straight line. So, I want to do that. Okay? So, this is our pen. This is the object. This is the object in black. I've drawn this part in red that appears to be bent, but the focus is the tip. Once we get it right, how rays behave from the tip, then we can draw the section that bends. Okay? So, for this tip to be seen by this eye, the rays from the tip must go to the eye. Okay? The rays from the tip must reach the eye. So how do I do it? I want to use the black ink. So I have there. I can have there, and then I also have that. This is, I'm shaking a bit there. So those are two rays I'm talking about. These are two rays, the black ones. They must reach our eye. But we are seeing that on reaching the surface, this is interface. This is what we call interface, boundary. Now this is boundary between air and this one is water. Remember? Refraction on plane surface. What happened at the boundary? Okay? There is water, there is air. These two are not of the same optical density. So what happens? They will be bending. They'll be bending. It cannot go straight this way. If this is the boundary and this is the tip, and then I draw a ray like that. Okay? This is the tip. I draw a ray up to the boundary. So this is the boundary. This is air, this is water. So what are we saying? In a nutshell, we are saying because air and water are not of the same optical density, this ray cannot go straight. it is wrong. Wrong. It can't go straight. It has to bend. And that is the essence of refraction. So we are saying it cannot go straight. So we are introducing something called the normal at the point of incidence. At the point of striking another medium on the boundary, draw a normal. So it cannot continue. It cannot continue like that. It will bend. So this is correct. It will bend. That is what we are studying. What happens at the boundary. So we are saying the two rays now, this ray 1 and ray 2. At this point, you draw the normal. You draw the normal. Then they will bend. So it bends. So it bends, and this one also will bend. Okay? So when they bend, they take the message to the eye. The eye see that on a straight line. So when you extend, dot, dot, again extend, you see extension gives you now the tip. The tip appears raised. The section in water is not real. So we put dotted line. Okay? The real ones are these black and blue. This one inside water, blue in air. Okay? You get it? So here, again, we can get it if you are still struggling. You can get it. This time I use this. This is the same. I want us to get again the tip only. If the tip comes here, ray 1, that is ray 1, you draw this. So the ray cannot continue on a straight line. It will bend. For example, that is what we are saying. Okay? Then we get maybe another ray, ray 2. Like that. Oops. Like that. So this is ray 2. Okay? Again, it will not continue straight, but you draw the normal and you give it that. So ray 1 and ray 2 appear to be bent. They are bent at the point of incidence. So what we are saying, this is the direction of the eye. Focus a bit, yeah. I begin. I had not focused the camera. So we have, this is the boundary there. Then this is the tip. So that tip, I want us to be, so there, I draw first, ray 1, and I have another, ray 2. So this is ray 1, and this is ray 2. This is my tip. That is my tip. This is my tip. The rays have gone to the boundary between air and water. So we are saying it cannot continue straight. They can't. They will bend. Okay? So I can draw that. May bend. Na hii nichore. May bend. See that? Okay? They have bent. Now, what is it? The impression, the eye, see, appears straight. The eye, it is straight. So this, if this is our eye, this is our eye. That is our eye. Okay? These lines appear straight. Them, they will not appear bent. There. And then this one also, you bring. So you see, to the eye it is straight. The dotted ones is extension, because they have to meet for you to see that image now. At least two rays have to meet for you to see the image. So this tip now appears here. Okay? It's the same thing even when you look at it straight. When we look at something at the bottom of the beaker or at the bottom of the pool, they appear raised. They appear raised because there is bending of light. When light emerges from one medium to another, there will be bending. That is what we call refraction. So this is what I can give you. You can try to draw, maybe. We can try to draw one, just maybe using a ray on, if you were to do some practice. Okay? If you were to do some practice, down here, I have here, do some practice. Okay? So you have a coin here. And this is the surface. Okay? This is what we are saying now. This is a coin. Okay? So, if you are following, if I take, for example, a point on the coin, that is a point. You see, a point helps you analyze issues very fast. If I draw a ray there and another ray here, for example, so these are two rays. Ray number 1, ray number 2. From the bottom of the beaker, I have ray 1, ray 2. Now, when they reach the interface, this is the boundary, this. Okay? Once they reach there, they cannot go straight. So, we repeat, they cannot go straight. They cannot. Okay? Now, if they cannot go straight, we are saying, at this point, if you can draw just a norm, like that, it will bend. This one bends. So that is the reality. It will bend. Then what about here? Also, it will bend. For example, it will bend. So this is 1, this is 2. This is number 2 ray. It reaches there, it cannot continue on a straight line. It bends. So the next lesson we shall see how or the extent of bending. Okay? For this lesson 2, you are trying to justify why is it appearing bent. So these are the real rays. Ray number 1 from the coin is this one. Ray number 2 is this one. At the interface, they bend. To the eye, the rays appear straight. The rays appear straight. So I'm going to do it using blue now. That this which goes to the eye, it will appear straight. So you extend. Even this, you extend. So the impression of our coin now is here. You can see this is dotted because it's not real. Okay? For us to see the image, at least 2 rays must intersect. So the real number 1 is here. It does not continue straight. It is bent because air and water have different optical density. Ray number 2 is this. It reaches here. It is bent. This in air going to the eye, ray number 1 going to the eye, and ray number 2 going to the eye appears to be straight. So we extend them because they have to appear straight. They cannot appear bent in the eyes. So they are extended backward, and now you get the image. The image appear raised. And that's why you will learn also this is real depth and this is apparent depth. So this is real depth and this is apparent depth. The reality is this, but it appears this. Apparent, not real. Apparent. Okay. So, folks, I hope you have enjoyed. I hope you have enjoyed that lesson. In conclusion, we are dealing with refraction of light on plane surface. Plane surface. We have seen that one in a homogeneous same composition material with the same optical density, light travels in a straight line. Okay, but when you have materials which have different optical densities, then light will bend. So refraction in a sense is the bending of light or the passing of light in different material of optical density as they change their direction. Okay, and then you can have an experiment to demonstrate that. I've done two. You can put your pen in a beaker and then account for the bending. You can also put your pen straight. The tip appears raised. The explanation and the diagrams I have done here. This is when it is put at an angle. This is when you are looking at it straight. The bottom line is the tip appears raised. A new term I've introduced there, real depth and apparent depth. So next lesson we are going to see how is the bending. What law, if any, governs the bending? Thank you very much. Keep on subscribing. Get your friends. Send a request like this. I'm doing it for the sake of somebody. There is another person who has given me many topics to go through. We have a lot of work also here. We are marking post-trial, but we shall see what we can do. Have patience. Read more. Read wide. Do not cram physics. Understand physics and maths. You will be a great person. Bye-bye.